Okay, this is going to be a screencast for Terminal Velocity Mission 2, lab number 3. The very first thing you'll need to do is read the lab intro and summarize what you will be doing during this lab and how Matt Brumbelow's work relates to this lab. And that's going to be found on page 61 of your textbook, the lab intro. So read page 61 and then write how this lab relates to his work in this space provided. That you will need to do before you show up for the lab. So this is part of your pre-lab. This needs to be answered when you come to class. The basic idea in this lab is to look at two things: velocity and momentum. And the way that we'll get that data is by running a car down a ramp. Now, if you remember, velocity is displacement divided by time. So if you measure this distance of the ramp and you time how long it takes for the car to go down this ramp, you will be able to calculate the velocity of the car. And then that leads us to the next idea, which is momentum. Momentum is going to be a little bit different in that momentum is an equation that takes into account the mass of the object times its velocity. So not only will you need to know how fast the car is traveling down this ramp, but you will need to know the mass of it. In this case, it's going to be kilograms. You'll measure it in grams and convert it into kilograms. And that will be the momentum portion. Then as you go down into the lab, some things to pay attention to are, okay, had to pause the video, so I'm not exactly sure where I left off. But I think it had something to do with when you get your data. Obviously, in your trials, if you're getting something like 2 seconds, 2.2 seconds, and then you get an outlier, just do it again. You need to make sure that all of your data is reasonably, what we would use the word precise, right? They are close to one another. And if it's an outlier, just redo it. Now, you're going to calculate both the velocity of the car and the momentum of the car. So you might want to look at how we do that. It's pretty straightforward. You guys know this. When it comes to velocity, remember, velocity is the speed of an object in a given direction. So it's a vector quantity. So it's going to be in a direction. So let's look at the equation. It says that velocity is equal to, I'll use DIS for displacement because that's a little bit different, divided by time. And when you are solving for a problem, you need to make sure, always remember to write the units. So here's a basic problem. Vancouver is approximately 225 kilometers north of Seattle. What is the average velocity of a bus traveling directly from Seattle to Vancouver if the trip takes 3 hours? Well, in this case, our displacement is 225 kilometers, and they said that it's north. So we need to put this in up here for north, because it's, if we just had kilometers, it would be a distance. This makes it a displacement. And we're going to divide that by the time it took to do that, which they said was 3 hours. And when you do the math on this one, pretty straightforward, you get 75 kilometers north per hour. And you'd be fine to leave it in these units if that was, if they didn't specify or need it to be in meters per second. Now, if you were to convert it into meters per second in our lab, you will need to. You would basically start off with 75 kilometers north divided by per hour, per 1 hour. And then we would do our thinking line. We need to get rid of kilometers, so kilometers would go on bottom. Meters would go on top. You know that there's 1,000 meters in 1 kilometer. This, remember, is your conversion factor. And then we would need to get hours. We need to go on top to cancel, seconds go on bottom, and you now probably know that there's 3,600 seconds in 1 hour. Kilometers north cancels, kilometers cancels, not north. Hours cancel, and that leaves us in 75 times 1,000 divided by 3,600. And when you get your answer, the calculator will give you the number. You're going to be in meters per second, and then we still have our north. All right. Okay. Now, the other calculation you'll need to do on this lab is one about momentum. And momentum has the equation P equals m times v. Now, what does that mean? M, you would think, might be the abbreviation for momentum, but m is taken with mass already. So we use the letter P as our abbreviation. And then we have mass times velocity. So let's say we had a basic momentum problem. It says momentum is a characteristic of moving objects. It describes the relationship between an object's mass and its velocity. So what if you had a 1,000-kilogram car traveling west at 18 meters per second? What is its momentum? Well, we have our equation. It told us that the mass of the object is 1,000 kilograms. So we have 1,000 kilograms. And we're going to multiply that by the velocity. And in this case, they said that it was 18 meters per second. And this is west, right? Because velocity is a displacement, so we have to have our direction. And so when we do our math on this one, you're going to get 18,000 kilograms times meters per second west. Now, the hardest thing about this problem, honestly, is the units. Kilograms don't cancel. You got meters per second, which don't cancel either. And we have our direction, which is west. So that leaves us with our momentum of 18,000 meters per second west. And that should do it. I'm going to cut it a little short because that's the bell for lunch.